The Sawhorse projection is kind of a 45-degree oblique projection of the molecule. Hey there, OChemNinjas. As we wind our way through organic chemistry, one of the things we're going to have to contend with sooner or later is that molecules are three-dimensional. They have a three-dimensionality. Some things are closer to you, some things are further away from you, but they have a three-dimensionality. We use the wedge and the dash notation to show which things are closer and further away from you in a line angle structure that's in the plane of the paper. Once we are okay with molecules being three-dimensional, the next thing we have to do is be able to manipulate them in 3 dimensions. The molecule may be given to us in a certain orientation, but it may make more sense to draw it in some other orientation depending on what our goal is for that particular structure. To that end, we can rotate around certain bonds, we can rotate the entire molecule or flip the entire molecule like a pancake. Those are manipulations that keep the molecule in the plane of the screen, and I have a separate playlist on those types of rotations and manipulations that I'll link to in the description. But an equally important way of manipulating molecules is to start to break it out of the screen, break it out of the plane of the paper, and start to rotate it in 3 dimensions. By rotating a molecule into a different perspective orientation, we can tell a different story about that molecule, and that story may be really useful for the reaction that we're trying to do. Maybe we need to see what the orientation of 2 groups are with respect to each other. Maybe we need to bring 2 groups really close to each other, or maybe the molecule has to adopt a certain conformation in order for a certain reaction to occur. Those are concerns for later in the course, but for now, we want to start getting comfortable with rotating this molecule into different perspective orientations in 3 dimensions, so that when we get to those places later in the course, changing the perspective will be an easy task. This video is about the Sawhorse perspective. The Sawhorse projection is kind of an intermediate projection between the line angle structure, which is in the plane of the board, and the Newman projection, which is a full 90-degree rotation of the molecule. You may not have gotten to Newman projections yet in the course, but that's okay. For now, the Newman projection rotates at 90 degrees so that one group's in front, one group's in back, and that way we can treat the different groups on the front and the back kind of like hands on a clock, and we can see how they're oriented relative to each other. If you're not familiar or comfortable with Newman projections, I have a whole entire playlist on Newman projections that I'll link to down below. The Sawhorse projection is kind of an intermediate perspective between the line angle and the Newman projection. If the line angle projection is in the plane of the screen and the Newman projection is a 90-degree rotation of the molecule, the Sawhorse projection is kind of a 45-degree oblique projection of the molecule. In the Sawhorse projection, we take the line angle structure and we start to rotate it out of the plane of the board. We only go a little ways, about 45 degrees, and we stop at that intermediate rotation. We call it a Sawhorse projection because the projection will end up looking like a sawhorse. The bonds in the southern hemisphere of the molecule will look like the legs of a sawhorse. A sawhorse, if you have 2 sawhorses side by side, you could run a plank between them and you could saw that board in half. That's why we call it the Sawhorse projection, because it kind of looks like a sawhorse. To draw the Sawhorse projection, we'll start with the central bond in the molecule, and we start it by drawing it up and a little bit to the right. We draw it in this orientation to show that perspective drawing of the molecule. As we start to rotate the molecule towards you, this carbon that's drawn a little bit further down on the page is implied to be a little bit closer to you as the viewer, and the bond that's a little bit higher up on the page is implied to be a little bit further away. That's taking this molecule and rotating it a little bit towards you so that the front carbon is towards you and the back carbon is away from you. As we go to add the decorations around these 2 carbons, we can draw these 3 bonds to this front carbon in a 120-degree orientation with respect to each other, kind of like that car company. Sometimes we call it the chicken foot orientation. We draw 1 bond straight up, 1 down to the right, and 1 down to the left. That represents these 3 groups on that carbon. The bond that's sticking straight up will represent this CH3 group that's in the plane of the screen, so it'll be up here on this top bond. You need to be a little bit careful when you add these wedge and these dash groups to these sticks on this molecule. Remember, it's a perspective drawing. We are not allowed to change the molecule, we're just changing our perspective of the molecule. This stick on the left will be kind of like this plank on the left in this Sawhorse projection. In this cartoon drawing of the sawhorse, notice that this plank on the left is kind of pointed away from you as the viewer. Similarly, this bond on the left is going to be pointed away from you as the viewer. As I take this molecule and I start to rotate it towards you, this hydrogen atom will end up on the left side of our new Sawhorse projection and will end up on the stick pointed to the left in the Sawhorse projection. Similarly, as this plank on the right is pointed towards you as the viewer, this bond on the right will represent the group that was closer to you in the line angle structure. As we rotate this molecule, this OH group that was on the wedge will end up being on the right side of our new Sawhorse projection. This is how we orient these 3 groups on the Sawhorse projection, keeping the same orientation of those groups. We follow the same process for the back carbon for the carbon on the right. We draw the same 3 sticks, 1 straight up, 1 down to the right, and 1 down to the left. Again, the stick that's sticking straight up will be the bromine group that's sticking straight up in the line angle structure. And again, we need to be careful how we orient the groups on the 2 other sticks. The bond on the left will still be this bond that's pointed away from you as the viewer. So as we rotate this molecule in 3-dimensional space, that chlorine will start to be on the left side of our new Sawhorse projection, and the hydrogen that's on the wedge will be on the right side of our new Sawhorse projection. This completes the Sawhorse projection drawing. These molecules are identical, they're just drawn in a different perspective. One of the nice things about the Sawhorse projection is it allows us to rotate the groups around the front and the back carbon without having to worry too much about where the wedges and dashes end up in the new rotation. As an example, if I wanted to rotate this front carbon so that the OH group was up on the top, that would be 120-degree rotation. I could rotate this front carbon 120 degrees to put the OH group up on the top. That's very easy to do in the Sawhorse Sawhorse projection. I would keep the sticks in the same place, and I would just rotate these groups like musical chairs. The OH group would rotate up to the top position, the CH3 group would rotate down to the left position, and the hydrogen would rotate over to the right position. This is how I could rotate that front carbon 120 degrees to put the OH group straight up. I could do something similar with the back carbon, but let's say I want to rotate the back carbon 180 degrees so that the bromine is pointed straight down. I can do that as well. I can rotate it such that the bromine is pointed straight down, and the other two bonds are pointed up to the right and up to the left. Doing that, the bromine goes straight down on the bottom bond, but I want to be very careful about where I put the chlorine and the hydrogen in this new structure. To get the bromine down on the bottom bond, I didn't flip the carbon like an umbrella. I rotated around that bond to get the bromine down into the bottom position with a 180 degree rotation. Because of that, when I rotate the bromine 180 degrees, that chlorine will also rotate 180 degrees and will end up on the top right side of the Sawhorse projection. The hydrogen will rotate 180 degrees and will end up on the top left of the Sawhorse projection. These rotations allow us to get lots of interesting perspectives of the original molecule. Why would I want to orient the molecule like this? I don't know. It doesn't really matter right now. Maybe there's something interesting about the oxygen and the bromine being on opposite sides of the molecule that allows for some cool reaction to happen. Doesn't really matter right now. What matters right now is we can take an original structure and start to orient and change its perspective and do some cool manipulations on that molecule in three-dimensional space. The Sawhorse projection is a different projection of the same molecule in three-dimensional space. We're not allowed to change the molecule. We can only change our perspective of the molecule in three-dimensional space.
Thanks for training with us today, Ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.